Hello again. In the previous lesson, we introduced sequences, series, explicit rules, recursive rules, and sigma notation. In this lesson, we're going to look at two things. One of them is called arithmetic sequence. The other one is called arithmetic series. And essentially, when it comes to arithmetic sequence, they change by adding the same number each time, and that number is called the common difference. Okay, so the common difference would be d is equal to a constant or whatever that term is, the difference of the sequence that is in question. So I do want to begin a little bit with these quick rules. So the arithmetic series has a constant difference of d. That's what this stands for. D is equal to whatever that constant is. And then the nth term is a sub n equals this expression here. So when we're looking for one single term, this is what we're using. We're looking for the 30th term, the 100th term, et cetera, et cetera. The sum is S sub n. So when we're looking for several terms, right? When we're looking for this is equivalent to looking for several terms. This is the equivalent of looking for one term. All right. So in any arithmetic series or a sequence, if it's a series and we need to use this. If it's a sequence, then we need to use this. Okay. This is looking for the summation of several terms. This is looking for the summation of one term. All right, let's go ahead and begin. So example number one, we have these values, 12, 7, 2, -3, and this is arithmetic, so we need to find D. So first of all, let's find the common difference between it. So what we're going to do is we're going to take 7 subtract 12, 2 subtract 7, -3 subtract 2. So let's go ahead and do that first. 7 minus 12 is -5. 2 minus 7 is -5. -3 minus 2 is -5. So notice we have, first of all, an arithmetic sequence, and that difference is a difference of -5. So that -5 simply means that there is a decrease here if you're going in this direction. Okay, so it'll tell you whether or not there's an increase, and it'll tell you whether or not there is a decrease. All right, so notice going from here to here, that's -5. Then from here to here, that's -5. Then from here to here, that's -5. Okay, so the difference is a -5. Now, what's interesting in this is the difference in -5. It tells us that there's a commonness in what's happening in this particular arithmetic series, and then this right here tells us that it's going to continue on indefinitely. All right, and then if you want to, we can say, well, if we're going from term to term, 12 minus 7 would give us, oops, excuse me. If we're going from term to term, we would use the number, or excuse me, n minus d. So the number minus d, so it'd be 12 n minus d. So the number is 12. 12 minus 7, or excuse me, 12 minus 5, excuse me, is 7. And then n would be 7. So 7 minus 5 would be 2. Notice the 2 comes next. And then the next would be 2 minus 5. Then we would get -3. So this particular arithmetic series checks out. Okay, let's go on to example number 2. Example number 2, we have a sub 1 equals 8 and d equals 6, and we're told to find the 20th term. So we do thankfully have some information that we can use. We have a sub 1, which equals 8, and then we have d, which equals 6, and we're told to find a sub 20. So we don't know what a sub 20 is. So essentially, since we're looking for one term, then we can use the arithmetic sequence here. So a sub n, which is equal to a sub 1 plus n minus 1 multiplied by the difference. So we're looking for the 20th term. So a sub 20, we know a sub 1, that would be 8. Parentheses, we're looking for the 20th term, minus 1. And then d, would be 6. So notice I just substituted this into the arithmetic sequence here. And then I'm going to compute 8 plus 19 times 6. 8 plus, that would be 54. 6 plus 5, that would be 114. Combining these together, we would end up with 122. So A sub 20 is equal to 122. Okay, but notice that we did not add the first 20 terms. We didn't have to do that. We could just find that one particular term. Okay, so pause and try the problem at the bottom. Okay, the problem at the bottom, the first term is a sub 4, or excuse me, a sub 1 is 4. So a sub 1 is equal to 4. And then we have to find essentially the common difference. So we have 4, 11, 18, and 25. So what we have to do is basically find the difference of these terms. So 11 minus 4, 7 minus 11, etc. Right? So 11 minus 4 would be a positive 7. 18 minus 11 would be a positive 7. And then 25 minus 18 would also be a positive 7. So notice we have a difference of positive 7, right? So we have a difference in this lateral series of, or lateral sequence of a positive 7. Now we can use the formula, which is a sub n equals a sub 1 plus n minus 1 multiplied by d. So we're looking for, it says write a formula for a sub n. So what we would do is substitute what we know, which is a sub 1. So a sub n equals, as a matter of fact, we'll write a sub n at the end when we finalize it. So a sub 1 was 4 plus n minus 1, and a difference of 7. 4 plus 7n. I'm using the distributive property. 7 times n is 7n. And then 7 times negative 1, which is going to be negative 7. And then finally, we can combine like terms. 4 minus 7 is going to give me a negative 3. And then I'm just going to put these in proper order. So a sub n, or the formula, write a formula for a sub n. That formula would be a sub n equals 7n minus 3. And again, we can find any term in the sequence using that formula. We can find the 100th term, the 1000th term, etc., etc. As long as we know what the term begins with, and as long as we know the difference between the several terms, then we can calculate what a formula would be. Let's continue. Example number 3. Example number 3 says that we need to find the sum of the first 30 terms of 3, 8, 13, and 18. So we begin essentially being asked to find the sum, right? So find the sum. So what we need to do is we need to use the arithmetic series formula. That arithmetic series formula is as follows. So we have S sub n, which is equal to n over 2 multiplied by a sub 1 plus a sub n. Excuse me, a sub 2, not a sub n. A sub 1 and a sub 2. Okay, as follows on the front. Okay, as a matter of fact, I did have it correct. I'm sorry. A sub 1 and a sub 2. Or a sub 1 and a sub 10. You have to pardon me because it's very late. All right, so a sub 1 and a sub n is essentially what we're going to use. Now, we do know the information that we have. We do have a sub 1. A sub 1 is going to be 3. And we do have a difference, right? Because if we did 8 minus 3, we would get 5. If we did 13 minus 8, we would get 5. If we did 18 minus 13, we would also get 5. So we see a difference of 5. So we have D is going to be equal to a positive 5. And then we're looking for the 30th term, so we're going to use n equals 30, right? So, but we don't yet know a sub 30, right? A sub 30 is what we essentially need to find. So how are we going to calculate that? We would say, okay, so a sub n is equal to a sub 1 plus n minus 1 times d. We're looking for a sub 30. A sub 1 is going to be 3 plus n minus, excuse me, not n. I need to put 30 there. 30 minus 1. And then the difference is 5. Okay, so we have 3 plus 29 times 5. 3 plus 5 times 9 is 45. 5 carry the 4, that'd be 14. So 145, which would be 148. So a sub 30 is equal to 148. Okay, so we know the last term, right? It says find the sum of the first 30 terms, even though this sequence goes on forever, but we're looking for the 30th term. So what we'll do is we'll use the sum formula, right? So the sum formula is as follows. So S sub n equals n over, I wrote 20 up here. You can tell I'm kind of sleepy, so forgive me for that. That's n over 2. N over 2 parentheses a sub 1 plus a sub n. So we're looking for the 30th term. So what we would do is write S sub 30. N is 30. That's 30 divided by 2. The first term is 3. And then a sub n is the term that we're looking for, so that'd be 148, right? And from there, what we're going to do is we're going to add these first. Actually, we can simplify both expressions. We can simplify this and simplify this at the same time. 2 divided by 30 is 15. And then this will generate 151. So S sub 30 is going to give us 2,265. Okay, so the 30th term is 148, and the sum of the first 30 terms would be 2,265. And again, forgive me for all the errors in this problem. I'm just a little sleepy. Okay, so a sub 1 plus a sub n. So this is n divided by 2, not n divided by 20. So forgive me for that. Okay. Now let's look at example number 4. So a person saves $20 for the first week and increases the amount by $5 each week. How much is saved in 12 weeks? Okay, so the weekly amounts form an arithmetic sequence. So week 1, $20 is saved. Then week 2, I'll have $25. Week 3, there will be $30, right? Because the person saves $20 the first week and increases by the amount of $5 each week. So 20, 25, 30, and so on. So the first term is 20. And then notice the common difference would be 5, right? So D is equal to 5. So we can essentially say, week 4, they're going to have $35 saved up. Okay. So again, if we did 25 minus 20, we would get 5. 30 minus 25, get 5. 35 minus 30, get 5. So on and so forth. Now, we want the total amount saved over 12 weeks. So we need an arithmetic series. So a sub 1 is equal to 20. We have D, which is equal to 5. And then we have n, which is equal to 12, because we want to know what the amount would be in 12 weeks. So first, again, we have to find the saved amount during week 12. So that'd be a sub 12, which is a sub 1 plus parentheses 12 minus 1 multiplied by 5, right? So again, a sub 1 is essentially 20. So I can just, as a matter of fact, I'm going to go ahead and substitute that value in there. And again, I'm just using a sub n equals a sub 1 plus n minus 1 multiplied by d. Okay, so I just went ahead and skipped ahead for that. Then 20 plus 11 times 5, 20 plus 55. 20 plus 55 is going to give me $75. So by week 12, the person saves essentially $75 during the 12th week. Okay. So again, this is essentially they save, a person saves $20 the first week and then increases the amount by $5 each week. So they're increasing the amount by $5 each week. Now, what we need to do is we need to find the total saved during all 12 weeks. So again, that's S sub 12 equals n divided by 12, a sub 1 plus a sub n. Okay. So n being 12 divided by 12, or excuse me, divided by 2. There I go again. Not 12, not 12, 2. I got ahead of myself. So 12 divided by 2, and then we're going to multiply that by a sub 1, which is 20, and then plus the $75 that would be generated. Okay. So this would be obviously 6. 12 divided by 2 would be 6. And then 20 plus 75 would be $95. So the final result would be $570 by the 12th week. And again, that's okay. So again, the person saves a total of $570 over the 12-week period. Okay. What's a common mistake? A student uses the sum formula when asked for the 20th term. Correct the method and explain the difference. Okay, so the student selected the wrong formula, right? The symbol a sub n represents one specific term. So if you see a sub n, that means the nth term. Okay, so you're essentially looking for one term. The symbol s sub n represents the sum of the first n terms. Okay, the sum of the first n terms. So if the question asks for the 12th term, then we need to use, or excuse me, ask for the 20th term, right? If it asks for the 20th term, we would essentially use a sub 20 equals a sub 1 plus 20 minus 1 multiplied by d. Okay, but do not use s sub n, or excuse me, s sub 20 equals 20 divided by 2 multiplied by a sub 1 plus a sub 20, unless the question asks for the total of the first 20 terms. So if it asks for the total of the first 20 terms, then you would use this. But if it asks for the 20th term, then you would use this expression here. Okay, so just again, one term, use a sub n. Total terms, or I should say total sum, then we need to use S sub n. Okay. So just a final review. Again, the arithmetic sequence essentially has a common difference of d, right? D represents that constant difference. Nth term, if you're looking for a term, then you want to use this formula. If you're looking for the sum of several terms, don't be like me and put 20 down here. um, take this formula here. S sub n equals n divided by 2, and then you want to multiply that by a sub 1 plus the value of a sub n. So again, you just have to calculate whatever a sub n is, and then you can complete this problem here. Okay, so this expression sort of fits inside this one very nicely. All right, that completes video 16, part 2, arithmetic sequences. And thank you again for listening in. I hope to see you in the next one.